So welcome to our recording of a Pack Pretend math class. This is stuff that we've talked about already to start with, and then we'll move on to circles, which we haven't talked about. Think about what we just did with note taking. And on purpose, we're starting with things that we've already done. So your note taking, you can just focus on the note taking. Make sure you have new topics, make sure any definitions you want to write stand out, things like that. I've tried to use on this webpage a good example to follow and do all those things we just discussed of what makes notes useful. So as you can see, there's headings that stand out, and wherever there's a definition, it's in the box, and so yours will look very different, of course, but the theory, the structure is all there. We talked about writing notes going down the page. We talked about having 2 or 3 columns and why you might want that. So let's see what works for you. So to review some geometry stuff, the perimeter of a shape is the distance that you would go around its edges. If I was to grab plus pointers, I pretend that I was an ant walking around that shape. I would want to pick a corner and keep track of that. It's an easy thing to do, especially if you're taking your brain will sort of fry with your test anxiety. Is to either not go all the way around or to forget you've done something double. Other than that, it's pretty easy. You know, 1, 2, 3, 4, 5, 6, 7, 8, 9. I was to draw that as a picture. Let's do it on the board so it stays in the recording. Then, where's my shapes? Let's make the shape have some color. Okay. Again, the danger is that I would either double count something or forget something. So what I like to do is actually make a little circle on the corner I'm starting with. And then we're going around this way. We're counting 1, 2, 3, 4, 5, 6, 8, and 8. Of course, in a math book on the GED, they're probably not going to give you little plastic tiles. Instead, they're going to give you something that way. If it has any numbers at all, would just be labeling the size. We'd say something like this side is 2 and this side is 3. And you'd have to think to yourself, well, if one up and down side is 2, then the other one is also 2, because that's how rectangles work. And if the bottom is 3, the top is 3. And then I'm going to pick where I'm starting and add up all the numbers. First I have 3, then I have 2, and then I have 3, 2, add them all up. It's also true that on most problems in a book with the GED, they're not just plain numbers. They're going to give you some sort of measurement. These are all inches. And so my label were those inches. And like we talked about in class last time, the number of things they put on the picture doesn't tell you what to do. Look for the actual instructions. If they put 4 numbers, 1, 2, 3, 4, maybe they want you to add them all up as perimeter. Or maybe they are instead asking for the area, jumping ahead a moment, and you're just supposed to pick 2 of them and let them multiply. They could give you more numbers just to be a distraction for asking for area. Or they could give you only 2 numbers for perimeter, and you have to know, oh, well, if that's 3, this is also 3. If that's 2, this is also 3. So don't get confused and assuming that just because they give you 2 numbers, area, 4 numbers, perimeter. Okay, let's stop for a moment and pause. Scale out just a little bit. Whoops. Okay. Would it help to have both physical things on the board? That's something you could always ask for in future classes. Say, teacher, it's nice that you write things on the board. You build it out in the box. Or you can say it wasn't enough to build it out in the box. Now there's no record in that. You can see that in the recording. When you put it on the board, where it says sometimes I'm using lots of colors and sometimes I seem to be using too many colors. Feel free to bug your teacher about that. If everything looks too much the same or is just overwhelming, or why is rainbow great teaching me, then ask for what works for you. Any other comments so far? Okay, I'm going to pause the recording. And let's go around and look at your notes and see what you. So our next thing to talk about after perimeter is the word polygon. We've been dealing with polygons, with the plastic tiles, with the wooden pattern blocks that were yellow and green, blue and red, but I don't know if we've ever officially defined it. So a polygon is a closed shape whose edges are straight lines. And by closed, I mean that I could draw something that isn't closed and then off. So maybe something goes over here, there. So that's something that has 4 lines. If I could draw better, they would be straight, but it doesn't close back up where it started. So that might be the path that you see your cat travel while watching it for some project or something, but it doesn't come back the way it started. I could also have something that has some straight lines. See if I can do this up here. That's some lines that are not straight. So that's also not a polygon. That might be some interesting work of art, but they're not going to call it a polygon. So check that you're understanding in your notes. Then first draw a polygon that has 7 edges. Second, draw something with 4 edges that's not a polygon. And I'll pause the recording as we. For the 7 edges, people did something that often works extra hard. You could try and make it shaped kind of like a stop sign, but with 7 edges and all the edges pretty similar. But you could also just go crazy. 1, 2, 3, 4, 5, 6, 7. There we go. 7 straight lines It's closed and comes back where it started. Doesn't have to look pretty, doesn't have to look symmetrical. Tell me what one of your 4 edges, but not a polygon, looks like. We'll point to it only. Okay. So again, there's 2 rules to break. You can either make it open, or you can make it not have a straight line, or both. So Daniel picked one that just looked like kind of Pac-Man. And by not closing it, then it was not a polygon. So, what else want to share? You got one? Okay. So Leo's was a little more square, but also didn't quite close. You had more sides on it. Okay, moving on. We talked about perimeter. The test, the GED is just going to give you a shape, label all the edges. If you don't label an edge, because it's a mirror or some other edge, like we talked about a moment ago with the rectangle, then your job is just to add them all up. As we said, remember to mark where you're starting. Because the mistake that people make on a test is to forget where they start. And then we're just going to add up all the numbers. 9, 5, 4, 6, 8. Let's see. Well, 6 and 4 makes 10. 9 and 5 makes 14. 4 and 8 makes 12. So 32, and it looks like this one is in meters. Okay. On the GED, you can use a calculator for this, and they probably will have edges with decimals or something, just not quite so boring. But on it, you add them up. Okay, do you want to do examples on your own? Are you good to keep going? We have done this before, so I don't want to bore you. Okay, I'll pause the recording. No, that not work. So for the top one, we just added them up. Make this a little less thick. Oh. So 3, 4, 5. 4 and 5 is 9, 10, 11, 12. For the bottom one, we have to remember that if the top is 6.1 for a rectangle, the bottom also will be. If one edge is 3, the other is 3. And now I need to go all the way around and add them up. So maybe I'm starting here. So a 6.1, a 3, a 6.1, 3. Remember, when I'm adding up numbers that have decimals, I have to keep my place value organized. So, in one's place, second's place, everything has to stay the same. So 0.1 and 0.1 will be 0.2. 6 and 3 is 9, 10, 11, 12. 6 and 2 is 8, so 18.2. Questions about either of those? Okay, You have the book in front of you. If you open it to page 417, section 8.1, we can see what the book did to talk about perimeter. It's probably true that in a future math class, they're not going to take time like this to help you compare the book in the lecture as the lecture is going. But again, many students like to skim through the part of the book that matches what's going to happen, and they kind of warm up their brain before. So let's see, how is the book different? They're organizing things a little bit. On the instructor notes, we're talking all about polygons first and all about circles next. Whereas in this book, they're doing, let's go around the outside of the shape first for both polygons and circles. And then they will do area as the next topic for both polygons and circles. So the ordering is a little their definitions are in boxes. That's kind of similar. They like giving you formulas. So the square is 4 times s, where s is the side. That's just the same, adding up as 4 sides. But they write it down. They give an example here. Yes, adding up 4 sides is the same as 4 times the side. If you like formulas, then this will make your brain happy. If you like just adding things up as a process, then this is going to look like making things too complicated. They give you nice example problems. Again, the online version of the book is fun because you have, give me something like that, and give me some physical book. This one will have a QR code that you can scan to get all those things happening. If you had the physical book, then the nice thing to do is take a piece of paper as you're reading. And when you get to example problems, go down slowly. And when you see the solution, stop. See if you can do the example problem. And if you get stuck, then uncover what you need. Maybe that's enough of a hint. And then keep going. Ah, there we go, and so on. For some students, that's not what they do the first pass through the book. They'll read through the sections, reading all the example problems, and then go back to the beginning of the section second time. Try it that way with coloring. So whatever works for you. And again, if the future class doesn't give you the right resources, bug the teacher. Say, you know, I need more practice problems. I need a practice test before this midterm, things like that. Okay. How could this be tricky? They could give you measurement units that don't match. So problem 103 has feet on one side and inches on the other. Do I have a picture here, or do we need to draw one? Copy that. Copy. Sorry, my keyboard is not working. Okay, so here we have a shape that is 20 inches on one side and 2 feet on the other. Is that what it was? 2.5 feet. And they're asking for the perimeter of that. If my units don't match, I have to make them match. I can't add up things that aren't the same. So which should I do? Should I turn the feet into inches or should I turn the inches into feet? Both could work. Okay, most people like that one because it gets rid of the decimals instead of making. So if I have 2.5 feet, then there's 12 inches in a foot. So 2.5 times 12, 12 and 12 is 24, and then half of 12 would be another 6. So we get 30. If you wanted, you could always use a calculator. Get your answer that way. So wherever I see a 2.5 feet, I'll just cross it out and put 30 inches. Now it's the same as before. I'm trying to find the distance around this. So wherever there's an edge that's not labeled, I need to label it. I should mark where I'm starting. And now I'm just adding things up. So 30, 20, 30, 20, bunch of zeros. 3 and 2 is 5, 6, 7, 8, 9, 10. So 100 inches total. Everyone happy with that? Questions, comments? So that was part one of how to make these tricky. And remember, the GED likes slightly tricky problems. So it would, I would predict much more strongly than not really just give you the perimeter where you add up the numbers. And do something like this, where one of the measurement units doesn't match the others and you switch it. The other thing is other way to make it trickiness is what we did before, where they don't give you every edge and you have to look for mirror image things. Remember the shape we did Tuesday that was like a bite taken out of the side of the square? So you've seen those. Okay, let's skip through this a bit. And we did area of polygons last time, but this is a great one to do. So while it's here, on Tuesday, we talked about why triangles take up half the space of the rectangle that surrounds them. If the triangle is just a diagonal line through the rectangle, it's pretty obvious that the bottom and the top were the same. That this much space is the same as that much space. For triangles where the top isn't one of the corners, there was the thing we did with scissors. We said, oh, I can take this part and cut it off and move it to be over here. And then it kind of made sense that, I have one triangle that's the original one and another triangle over here, and those are the same. So the original triangle really was half of the rectangle we started with. Is that enough to ring a bell from last time? Okay, so I'll back up out of that. Your job is to find the area in squares. You don't know if these are feet or whatever. But what's the area of these shapes? We did not talk about trapezoids, so ignore this one. We're not doing that. But for the 4 shapes on the top, find their area. I'll pause the recording and then we'll talk about it. Okay, talked about this a little while the recording was paused. If there are certain things that the instructor doesn't write that are helpful to you, like maybe this stuff over here, then that's a good reason to be taking notes. The instructor might just put this thing up for that problem, not phrase it that way. So whatever works for you, make sure it's in your paper. The parallelograms are easier than the triangles. There's no 1/2. Can you see that if I took this yellow bit and moved it instead over here, then that would just take this bit and we could turn it upside down and put it over there. So I can cut off this column most on the right, put it over here, and I would get the same rectangle. So the parallelogram in orange is actually the same size as that rectangle, because I'm just taking this part and moving it. So whatever the size of this red rectangle is, that's the size of the parallelogram. We did that by physically cutting paper on class last time. So how big is that rectangle? Let me draw it a little more nicely. So I want to find out this area. In the textbook, they're going to draw a line and say, what is the height of my parallelogram? They're not going to draw a rectangle surrounding it like this paper has. Okay, what was the base of our parallelogram? Five. Yeah, don't count this extra little piece. That's not part of our one that we're talking about. So all it is, 3 times 5 is 15. Similarly, for the other parallelogram, the height is 3, the base is 3, so 3 times 3 equals 9. Okay, while the recording was paused, we talked about notes, and when you switched from perimeter to area, you can make a nice topic heading. As you're taking notes, is the description of how to do things, not blurring together too much with the example problems. Whenever you talk about how to do something, is there an example problem, and so on. Do you have to copy down all the example problems the instructor does on the board? Probably not, because they're in the instructor notes. There's similar ones in the textbook. That would be an awful lot of writing for stuff that's already there. But whatever example problems work best for your brain, the ones that you will want to see these again while you're cramming for the midterm or the final or the GED, those are the ones to have on your paper. Being exhaustive and complete isn't going to help, just the ones that make things work. Okay, we did all of that, great. Okay, now we're going to talk about circles. At this point, we could stop also talking about note-taking. Is it too awkward to be trying to have like 2 lessons going at the same time? Okay, so should I stop the recording, or do you want to have this at the end of the day recorded in little anyway? It's easy to keep recording. Keep recording? Okay. So I'm going to pretend we're all done with note-taking. Actually, let me pause and we'll talk more about note-taking. Then, okay, talking about circles, we're reporting. While paused, we took some brave volunteers, held string up by arms and by heads. And the question is, how many widths does it take to go around the circle? And arms and heads aren't really round. We have a ab wheel exercise thing. And you can see in front of us that if I unwound the string around the wheel, then how many widths of the circle does that take? It was 3 and a little bit. So same thing you just did, but now you have an animated this report. So mathematicians have made a name for this answer. How many circle widths does it take to go around the circle? And because they are strange, they decided to name it the Greek letter, and that's where we get pi. So there's nothing magic about pi. There had to be some number that was the answer to this. How many circle widths does it take to go around the circle? Whatever that is, they called it pi. Yeah. So this is a kind of useful thing. If you wanted to build a winch, then how much rope would you need to each time you go, you crank the winch around in a circle, how much rope goes up, that kind of thing. So you can see why they wanted to do this when building stuff. Okay, yeah.
Did they have real pi with that cycle over?
Did they have
Like actual pi with business now?
maybe?
Or did they actually like not the pi with the
Oh, I don't know enough about ancient Greek listening, and I don't know why they named that letter pi.
Is it really just a letter called pi?
Yeah, in English we wrote it PI, so we don't get confused with pi.
In their alphabet, it's just called pi.
It's just called pi. Yep, just like we have a letter called A.
That's weird.
It is. Anyway, so ta-da, there we go. No one was using that Greek letter for anything, so they called it that. Now, here's another interesting thing. If I have a square, imagine this is one of our plastic squares we use so often. If I label the side of it R, then the area is R times R, which I could also write as R squared. Area of the square multiplied with its side. If I make 4 photocopies of them, then I have 4 R squareds sitting on the paper. Everyone okay with that? One of them is 1 R squared, so 4 of them is 4 R squared. Now I'm going to ask you another circle question. If I draw the biggest circle that fits in that square, how much of the square does it cover? Now you can see why we use R 2 pictures up. Is this part of a circle, the distance from the middle to the edge usually has R for radius. That's what's there. So the whole big square is 4 R squareds. How many of those does the circle cover? Certainly more than half. There's only these little kind of winged things, cat ears sticking out of the corners. Does it look like it covers more than 3 of the squares? It's not all 4, because again, there's this brown stuff still sticking out the corners. So I can't prove it to you with the math you know, but fortunately, the answer to this question is the same as the answer to the other question. That covers 3 of those R squareds and a little bit more. It covers pi of the R squareds. And that's nice, because otherwise, on my calculator, we'd have to have 2 buttons. The pi button for when we're dealing with distances around the circles, and some other thing for when we're talking about how much area, how much paint. But since the answer is the same, the pi button, they're both. Yay, 4 buttons. Your textbook will write that differently. it will say something like for a circle, let's make it not. Okay. It's going to say that the circle has some distance across. And the whole distance across we need a name for. So we're going to call it D for diameter. I'm not sure why they do this. There was the word width. Width was a perfectly good word. I'm not sure why we have to have a different word for circles, but we do. And then the circumference, the distance around the circle, and again, circumference is a fancy circle word. We had a perfectly good word of what's the distance around a shape already, of perimeter. They just mean the same thing. So it's pi times that diameter. For area, the picture is a little different. Instead of the distance across the circle, we just care about the distance halfway across the circle. There's another copy of the radius. Oops, that we don't care about over here. 2 radiuses makes the diameter. And the area for how much space the circle takes up, if I was to paint it, is pi times the radius. Oops, I should make an x times the radius again. And if you like squared as a notation, then you could write that as pi times r squared. It means the same thing. I actually like the top better, radius times radius, kind of spelled out the long way, because some people will rewrite the top formula as pi times, now diameter is 2r, so you could write that 2 times r. If you're used to this and this, they look too similar. They are both things that have a pi, a 2, and an r in them, and people get confused. So my advice is to ignore that and think about one equation that has pi times diameter and the other equation that has pi times, oops, I would ignore that, and the other equation that has pi times r times r. Hopefully these things, although you want to memorize them, actually you don't need to for the GED, I'll talk about that. Then you should have some back of your brain memory of where these came from. This one was when we were wrapping string around Mackenzie's elbow and Daniel's head. How many widths go around? And this one was the picture where we had 4 boxes. And how many of those 4 did the circle cover? A little more than 3. Okay, in our Moodle, since I just did a thing, then oops, I need that table of contents, GED info. You can see that there's an official GED formula sheet. You can look at which formulas they will give you on the GED, including a lot about perimeter and area. You don't have to memorize them. They will give you this paper when you're taking the GED test. Okay, so we have two different formulas now. And let's do some practice problems. Sound good? I want is I don't want the second one. Okay. Let's do that one. Get everything on the board. Bigger. Just got very big. Can you see this? Is the layer too big? So we have one where halfway across the circle, the radius is 2, and the other where halfway across the circle, it's a half. And it asks you to find both things, the perimeter and also the area. I'll pause for a minute. So for the top one, whoops, I went. There you go. If halfway across that first circle is 2, what's all the way across them? 4. Yeah. We've talked about it a little bit, but not much. If I am rounding my answer, it's polite to use the squiggly equal sign symbol instead of the normal equal sign. That tells whoever is reading your work. In this step, I just rounded. And with pi, there's always going to be rounding. Okay, so pi times 4, it's about 12.6-ish. And this was in inches. Now, pi times 2 times 2 is again going to be pi times, whoops, 4. So we're going to get the same number. And it's again rounding, so I'll use squiggly. But this means something very different. Now we're talking about square inches. We're talking about how many tiles would it take to cover this? How much paint would it take to paint this? So if I was to write it on graph paper, how many squares would it cover? That kind of Now my calculator isn't going to like the fraction of 1/2. When we need to, we can change that into a decimal. Okay, don't think too hard. If halfway across is a half, what's all the way across? A whole. So that's just going to be 1 pi times 1. $3.14159. If you're a math person, you would have memorized that. If not, who cares? The calculator tells you. So about 3.1. It's in inches again. So instead of a 1/2, what should I put to make my calculator happy? Yeah, 0.5, 0.5. So about 0.8. In real life, how much to round depends on what you're doing. Are you doing carpentry with a saw? Cutting to 1/10 of an inch. That's about as accurate as I can be with a saw. I can't cut to the 100th of an inch. If I'm in the pharmacy and I'm measuring things with a scale, then I can do several decimal places and so on. Okay, I am going to screen snip this so that people can see in the future where all those numbers came from. I also want to talk about why I wrote the way I did, since we're doing these for the first time, and also because we're talking about note taking. Notice my equal signs lined up for each problem. Things don't dance all over the page. Even though I know these formulas, I write them out each time. And I try and line things up so that I can see where I am putting the numbers in. Everyone, especially on a test anxiety makes our brain fried, is going to put the wrong numbers in. They might put the 1/2 in instead of the 1 right here or something like that. So having everything written neatly means that I can go back at the end and double check my work. Make sure I plugged in the right numbers into the right spots. It also means that if I am studying with somebody, then I can look at their paper and see what they did and compare it to mine. And as we talked about after the midterm, if I don't have a real person to study with, then I could use ChatGPT. It puts out my step-by-step answers. I could ask that website, what's the perimeter of the circle whose radius is a half? And I compare what it does with my work. You want to see that on the board right now? Okay. So that is not in. So I could open up ChatGPT and say, what is the perimeter of the circle whose radius is 0.5? Okay, that looks quite a bit different than what we did. It uses the twice radius, not diameter. Plugs things in. That's the same answer. Maybe that helps you, maybe it doesn't. Most people like studying with real people more than studying with ChatGPT. But if work and busyness and stuff means you can't actually get to a study group, this might be the best thing. And remember, with the large language models, you can fuss at them. So I can say at the bottom next that I want the answer in using the diameter, not the radius. Ah, there we go. This looks more like what I was doing. So. Just like part of today's theme was complaining to your teacher if they're not giving you the right resources, then, oops. Chatbots, you can also fuss at them till they give you the way you want it done. Okay, here's some kind of basketball, maybe ice skating rink, who knows what shape this is. It's only a few inches, whatever it is, it's for ants, not for people for sports. Finale, wrap-up question. If you can do this one, you can do anything. This is about as hard as I could possibly make it without being extra annoying and changing one of these into feet just to be a bad person.